These examples are to correspond with the lesson Simplifying Rational Expressions. As part of a refresher, I just want to point out that I do have listed here 5 special factorizations, which you will see some of them in the examples that follow, but this is just for easy reference. Okay, so let's get started with simplifying the rational expression 4x divided by 2x squared. I also, with a few of these, I want to go ahead and state what the domain would be. As a rule of thumb, for rational expressions, the domain, which I usually note like this, you start off by stating all real numbers, which I'm just going to call all reals. Okay. Because with rational expressions, we use sort of a backdoor approach by stating the values that are excluded. That's why I have to go ahead and state that I do start off with all real numbers, and then I'll find out the values that I get to leave out. Alright, so here's my setup for my domain. In order to find those exclusion values, I look at the polynomial in the denominator. So 2x squared, and I set it equal to 0 and solve. So I can immediately divide both sides by 2. So 2 divided by 2 is 1. That gives me x squared equals, well, 0 divided by 2 is still 0. So the only solution for this is if x itself equals 0. So that is my exclusion value, is 0. There's my domain. X is all real numbers except 0. Now, let's go ahead and simplify this. So write out the original problem. And I usually do this just to sort of give myself a little more space to work with. Okay, I'm going to completely factor the numerator into its prime factors. So that means 4 is 2 times 2, and then x to the first is still just times x. In the denominator, 2 is already a prime factor, so I'm going to go ahead and use 2 times 1. And then x squared is the same as x times x. Alright, this actually, writing it out this way makes it a little bit easier to see where the common factors are between the numerator and the denominator. So I see there's a common 2, so let's cancel those out. 2 and a 1, we don't have to do anything with those. Those will sort of take care of themselves. And then a common x between the numerator and denominator. Okay, let's look to see what's left. In the numerator, just a 2. In the denominator, x. So our simplified rational expression is 2 over x, and the domain for this expression is all real numbers, and x cannot equal 0. Okay, next problem. Simplify the rational expression 2 divided by 2x plus 6. Again, I'm going to find the domain first. It's always easy to do it with the original expression, just in case you get things that cancel out that would affect your domain. So I always like to do the domain first. So all reals. Remember, this stands for all real numbers. I'm just abbreviating it because it takes me so long to write on here. And then I put a comma, and here's where I list the values that x cannot equal. Now let's go find them. I look specifically at the polynomial in the denominator, and I'm going to let that equal 0 and find out those exclusion values. Subtract 6 from both sides. So I have 2x equals negative 6. Divide both sides by 2. And I get that x is equal to negative 3. That's my only exclusion value. Alright, so the domain of this rational expression is all real numbers with x not equal to negative 3. Okay, now let's actually simplify. So I'm going to rewrite the original problem. Okay, the numerator, since it's already prime, I'm going to write it as 2 times 1. That way I remember if the 2 disappears, there's still a 1 left in the place. In the numerator there. Okay, in the denominator I have a binomial. I always look for a greatest common factor first. The greatest common factor here would be 2. So I pull the 2 out front, times, and let's see what's left over when I divided out that 2. Well, here there would be just the x, and this would turn into a plus 3. Okay, everything is completely factored. So now I look for similarities. I have a 2 factor in the numerator and a 2 factor in the denominator. So we cancel those. 1, we are just using it for a placeholder, and x plus 3, there's nothing we can cancel that with. So our simplified rational expression is 1 divided by x plus 3. When something is the only remaining factor left, like this x plus 3 binomial was the only remaining factor left, we don't have to have the parentheses. We can drop those. Next example. Okay, now if you remember the list of special factorizations that I showed at the very beginning of this video, and if you are at least a little bit familiar, you should recognize possibly 1, maybe 2 different quick factorizations that we can use. So before we get started with that, let's go ahead and get ready to do the domain. So the domain is all reals except x cannot equal, and where do we look to find out what x cannot equal? Well, if you're thinking the denominator, you are correct. So take the denominator, x squared plus 16x plus 64 equals 0. With any trinomial, if you can factor it to solve, it's usually a lot quicker. And this one is actually a binomial squared. So if you were to multiply x plus 8 times itself, you would get x squared plus 16x plus 64. So there's your binomial squared equals 0. And we can take the square root of both sides. Or actually, we don't even have to do that. Each factor gets set equal to 0. So since x plus 8 is just repeated, I'm only going to write it once. But you could write x plus 8 equals 0 or x plus 8 equals 0 if they happen to be two different factors. But since they're the same, I'm just going to write it once. Subtract 8 from both sides. And I have x equals negative 8. That's the one that I want to leave out. So that number goes in here. So the domain is all real numbers except x is not equal to negative 8. Now, in doing this work to find the domain, I actually helped myself out just a little bit. I already know how this thing is going to factor. So let's rewrite our original problem. So we've already got half the battle for just the simplification. We've already got that half won. Okay, since I already know how the denominator factors, I'm going to go ahead and write that in there. That's going to save me time. X plus 8 quantity squared. Alright, now let's look at the numerator. This is probably one of the easier ones for people to remember. It's always easier for me to remember it. The difference of squares. So go ahead and write your 2 sets of parentheses. The first term is the square root of the first term in the quadratic. The second term is the second term, is the square root of this second term here. So square root of 64 is 8 and 8. And since this is the difference of squares, that means that it came from multiplying x plus 8 and x minus 8. Okay, now it may be more helpful if you actually write this x plus 8 quantity squared if you write it as two factors side by side. So let's go ahead and do that. I always like writing it that way. It makes me feel like I'm actually seeing where everything is going. So x plus 8 times x minus 8. And then divided by x plus 8 times x plus 8. Okay, so x plus 8 and x plus 8, that gets rid of a factor in the top and a factor in the bottom. And the x minus 8, x plus 8, we can't do anything else with those, so we just rewrite those. X minus 8 divided by x plus 8. Okay, next problem. This one is actually a lot simpler than some people think, but there's something you should not overlook. In the numerator you have positive 10x minus 6. In the denominator you have negative 10x plus 6. The difference between these two, the only difference between these two, is the sign on each term has been changed between the numerator and denominator. So we went from positive to negative and negative to positive. So in the numerator, I'll go ahead and factor out a GCF. Looks like it's 2. And in this case, I'm not going to rewrite because I'm running a little bit short on time. So pull out a 2, and I'm left with 5x minus 3. Okay, so since these two look pretty close to me, here's the little trick. Try pulling out a negative number. Because if you pull out a negative and you get the same signs as what's in the numerator, then you know exactly how it's going to simplify. So I pulled out a positive 2 in the numerator. I'm going to pull out a negative 2 in the denominator and see what happens. Well, if I do that, then negative 10 becomes a positive 5x, and a positive 6 becomes a negative 3. Aha! Those binomial factors match, so we are going to get rid of those. Now I'm left with 2 divided by negative 2, which that's pretty easy. We simplify that down to negative 1. All right, I think that's all I have time for on here. Don't forget for this last example, if you were going to find the domain, again, just take the denominator and set that equal to 0 first, and that gives you the values that you exclude from the set of all real numbers. So anyway, if you have any further questions, please do not hesitate to leave a comment and ask.